Hi everyone, I am Trevett and I work on developer ecosystems at NVIDIA and I am president of the Khronos Group. And I'm happy to have the opportunity to speak to you here at Virtual SIGGRAPH Asia. Over the next hour, I'm going to be joined by some of the Khronos members that are leading key Khronos initiatives. And together we will bring you up to speed on the very latest developments in open standards for 3D graphics and virtual reality. Also, all of these presenters will be available at the SIGGRAPH Live Q&A on December 10th, Singapore time, or December 9th for those of us here in California. And we look forward to answering any questions that you may have. Let's start by introducing Khronos if you haven't come across us before. Khronos is an open standards consortium. We provide a safe place for the industry to cooperate and create interoperability standards. These standards enable applications to access the power of 3D graphics, virtual and augmented reality, and parallel computation. We are a non-profit organization, and all the standards we create are open and royalty-free for the industry to use. We have been creating open standards for 20 years and have almost 160 members, and that includes everyone from the largest companies down to small startups. And 30% of our membership is in Asia. Any company from around the world who wishes to join Khronos is welcome to participate, to have a voice and a vote in how Khronos standards evolve. Here are the standards currently being most actively developed by Khronos. There are four main groupings: 3D acceleration APIs, including Vulkan, WebGL, and the new ANARI for analytic rendering. Next, we have initiatives for 3D asset formats, including Jltf, the Openxr API standard for portable, augmented, and virtual reality. And on the right, a family of APIs and languages for parallel computation, vision acceleration, and inferencing. Each of these open standards is created and evolved by a specific working group within Khronos. And each working group has a chairperson who makes sure things run smoothly. And we're going to hear today from the chairs of the standards I mentioned, outlined here in red. But first, let's talk about Jltf, the Khronos 3D asset format that is focused on being ubiquitous, compact, and easy to process. And so we like to call it the JPEG of 3D, as it is the last mile JPEG equivalent that lets you easily transport and deploy and use your 3D assets wherever you need, including in this PowerPoint presentation. Jltf uses JSON to describe the 3D scene or asset hierarchy and uses binary payloads to describe geometry, animations, and skins. Textures are included as JPEG, PNG, or KTX files, and Jltf has Pbr, or physically based rendering, for materials that are very accurate and realistic, and we'll hear more about that in just a moment. Support for Jltf is now widespread throughout the industry as companies realize the efficiency and cost savings of having tools, apps, and engines that can all communicate assets easily to each other. The companies shown here have all implemented Jltf support, both in tools that generate Jltf assets and engines and applications that ingest those 3D Jltf models. If your company supports Jltf and your logo isn't here, please let us know. We would love to add it. Jltf is an extensible standard to enable it to evolve to meet industry needs. One of the most widespread developer needs, of course, is for small, compact asset file sizes. The Draco mesh compression extension uses compression technology developed by Google and is now widely adopted by the major 3D tools and engines with encoders and decoders in open source. The Draco extension enables geometry in a Jltf file to be compressed, typically by a factor of 10 to 25 times. Khronos is also very close to finalizing Jltf universal textures for efficient and flexible texture compression that complements the mesh compression to enable very compact asset files. Universal textures use basis universal royalty-free encoding and transcoding technology from Binomial and uses KTX version 2 as a container file format to provide consistent cross-vendor access into texture asset internal structures, such as bitmap levels. This enables smaller than JPEG textures that are directly transcodable into almost any GPU-accelerated texture format on the fly, so textures need never be stored as fully decompressed images on the GPU, saving a significant amount of GPU memory. Next up on the GLTF roadmap is a next generation of Pbr Material Properties, which are being designed by an amazing group of experts from member companies, and they are guiding the GLTF standard to a sweet spot between visual realism and widespread deployability. Chairing this GLTF Pbr initiative is Ed Mackey, who's going to give us a status update. Over to you, Ed.
Hi, my name is Ed Mackey. I'm from Analytical Graphics, and I'm going to tell you over the next few minutes about next generation Pbr materials for GLTF. GLTF is a 3D model file transmission format. It has used Pbr, that's physically based rendering, as its material model for, since the release of 2.0 in June of 2017. And it has the 6 parameters that you see here on this water bottle sample model. GLTF also features an extension mechanism where additional parameters can be added in a controlled namespace kind of a way. And we have released a couple of extensions for adding new material properties, such as clearcoat. Clearcoat has its own roughness channel. It has its own normal map. It adds an extra layer of shine and polish, similar to what you might find in the automotive industry, without breaking the laws of energy conservation, of course, so you don't get an unnatural shine on things. We also have transmission. That's our most newly ratified extension. Transmission is for materials like glass and tinted glass and frosted glass. It allows light to pass through the material, but it does not get rid of the specular reflections that would be on a shiny transmissive surface. It also uses the roughness channel from the base layer to blur the transmission. And sheen. Sheen offers its own roughness and a sheen color channel, and it simulates the effect that light has hitting little microfibers in the cloth, so you get more of a clothy look. Is that a word? Clothy. Our future plans. We're going to tackle some more challenging extensions with volumetric properties like subsurface scattering, attenuation, and IOR. And we're asking for input from engine developers and artists and anyone else who has a stake in all of this. Let us know which material properties are most important to you. You can do that on the Khronos forums, online, on Twitter, or better yet, if you're a Khronos member or if you're able to join the Khronos group, we'd love to have you. Come find us in the Pbr TSG. That's a subgroup underneath of 3D formats inside of Khronos. And let us know what you think. Thank you for your time.
Thanks, Ed. Now, one of the newest Khronos working groups is 3D Commerce, which is working to enable the use of 3D in e-commerce at industrial scale. The work of 3D Commerce is largely based on GLTF and is now significantly influencing GLTF's roadmap, including the Pbr extensions that Ed just told us about, and a new metadata extension to hold information on product configurations. The 3D Commerce and GLTF working groups are closely cooperating to create sample viewers and certification tools to ensure that GLTF 3D assets can be accurately and reliably displayed, whatever the end user's device or software. So why is the 3D Commerce initiative happening at Khronos? Well, Khronos has a long history of creating open standards for 3D graphics. The industry's leading 3D technology companies, including platform owners, GPU vendors, and 3D software developers creating tools, engines, and applications, are already Khronos members. And so when the world's leading e-commerce companies needed an organization to host cooperation to build standards for the use of 3D technology in e-commerce, Khronos was the natural organization to approach. So in response to this outreach from the retail industry, Khronos established a new 3D Commerce working group, available for any Khronos member to join. The 3D Commerce working group now brings together a unique mix of technology and retail companies. Due to its diverse membership, the working group has both real-world insights into 3D commerce challenges and use case requirements, and the technical expertise to create standards and guidelines that will be effective solutions to those challenges to bring 3D commerce to industrial scale. So now The 3D Commerce Working Group is successfully leveraging GLTF and other Khronos standards to enable the widespread deployment of 3D in retail. It's really great to see these low-level Khronos standards such as WebGL and GLTF being leveraged by diverse vertical applications such as 3D commerce. And now to learn more about the requirements and goals of 3D commerce, I'm very happy to introduce Shrenik, who is the chair of the 3D Commerce Working Group. Over to you, Shrenik.
Hi, everyone. Welcome. Thanks for taking the time and thanks for joining us today. My name is Shrenik Sabalgi, and I'm the chair of the 3D Commerce Working Group. In my day job, I work for Wayfair, where I lead a small team that is trying to figure out the future of retail and home by investigating emerging technologies. But today, I'd like to talk to you about 3D commerce, why we are here, why we created the group, and what our goals are. When you think of merchandising and the way it's evolved, we've gone from text descriptions of products to images that represent products to now 3D. I believe 3D is a medium that is very impactful for merchandising, especially when you think about the visual computing technologies such as augmented reality and virtual reality, where you can let customers place products in their space or immerse them in virtual environments and have them engage with your product and your brand in a more meaningful way. Before we can see widespread adoption of 3D in retail, there are a few hurdles that we need to overcome. And let me try to illustrate this with some examples. So let's take search as a use case. Google just announced support for 3D and AR search. Now, what that means is you could search for a product and actually see it, engage with it in 3D and place it in your space and then purchase it. And there are many experiences like this where 3D is becoming a lot more powerful in the discovery process. So imagine this across multiple platforms now. Because of the inherent rendering capabilities and the differences in the underlying platforms, to an end user, this chair is going to look a little different across different platforms. Visually, it is not going to be consistent. There are going to be small, slight differences. That leads to a poor customer experience, where the customer does not know which specific platform is the best one to use in order to perceive the product correctly. So that's one problem, and that's on the end user side of the spectrum. Where does this content come from? How do you produce this asset in the first place? What are the problems in that part of the world? So as an example, a manufacturer who wants to sell a product relies on either a retailer or a shopping platform to actually help them sell the product. The retailer or the shopping platform usually employs a team of content creators or employs a service of content creation, where a team of 3D artists then use 3D tools to actually produce the 3D content. So you can see that there are multiple actors and multiple roles that people are playing in multiple organizations to actually produce content. So when you zoom out a little bit and take a holistic view of the entire supply chain and this pipeline of how a product gets created and how it's finally displayed or experienced on a device, multiple people have different definitions of what a virtual product is. And we need to, the problem with that is that as content exchanges hands, that definition changes. And people need to create or recreate assets based on different definitions. This workflow would be a lot more streamlined if we all aligned and actually agreed on what a virtual product is, what constitutes a virtual product, and what defines a virtual product. And that's one of the reasons why 3D Commerce was created. Our mission is to create specifications and guidelines to help with this asset workflow. all the way from product design and manufacturing to the end customer experience. In a simpler way, we want people to be able to create virtual products once in an easy way and have them be able to reuse it across different platforms without having to worry about how that product would look, how people would experience that product. A content creator should have confidence in what they're creating. Will that product withstand time, and will it withstand multiple platforms? Does it have the longevity to do that? That's what we are trying to do. That's the mission. So trying to break that down into the sub-problems, the first one that we're trying to tackle is achieving that visual consistency across platforms. A virtual product should look the same when you see it across different platforms. That's critical to provide a good, consistent end user experience. When you think of products come in multiple shapes, sizes, and colors. But how do you package all that stuff up? How do you do that intelligently so that the content creator can actually do it in an easy way, in a very well-defined way that works well across multiple platforms and can get distributed over the internet and over the wire to the end user devices? Currently, there's no way of doing that. So we plan to create one. And that's one of the goals of 3D commerce as well. When you think of information about the product, where does that information lie? Should that be embedded inside the product, inside the 3D model, or should that be separate? What kind of information should be embedded in the 3D model? So we're trying to figure out answers to these questions. Metadata, like description of products, the names of the products, something as simple as that. Something more semantic, like where does the product attach to the physical world? What I mean by that is, how does a product interact with the physical world? So for example, a couch, does it fit on the floor? Does a chandelier hang from a ceiling? Does a wall sconce hang from the wall? Things like that, where we're trying to figure out how do we embed that kind of information into the 3D model itself. And last of all, how does someone produce this content in the first place? How do we educate everyone to ensure that people are creating content in a streamlined way that's not wasteful and that's a lot more efficient? In fact, we have released the first version of a set of asset creation guidelines that would help content creators create an efficient asset that would work on multiple platforms. So here's a set of problems that we're trying to tackle as in the short term. And as the group evolves and as we tackle some of these problems, we will take on a different set of problems. And that's where we need your help. We want you to be involved in this effort, especially if you're in the 3D commerce ecosystem, if you're a content creator, if you're a developer, if you're a DCC tool provider, if you are a manufacturer, a retailer, a technology platform, if you're involved in anything to do with retail and 3D technologies, you should be involved. So check out the website, go to khronos.org/3dcommerce, send us an email, 3dcommerce-feedback@khronos.org to be involved. And definitely check out the first version of our real-time asset creation guidelines. There is a QR code on the screen here. Please try to follow the link and give it a read and let us know what you think. It's a living document that we've hosted on GitHub, and we expect, we would love your feedback on it. We believe that with your help, we can refine the document to a point where it can be broadly distributed and be followed and lead to more streamlined and efficient asset creation. Our goal that you see on the right here is render everything everywhere. I'll end with that. Thank you so much for your time.
Thank you, Shrenik. As Shrenik has thus explained, enabling and encouraging the creation of efficient and reliable 3D assets is one of the key goals of 3D commerce. And so now we have Nathaniel from DreamView, who's going to give us more details on how the working group is furthering that goal.
Welcome to the SIGGRAPH Asia 2020 Khronos 3D Commerce Asset Creation Discussion. My name is Nathaniel Hunter, and I am the co-chair of the 3D Commerce Asset Creation subgroup. I'm also the Chief Operating Officer at DreamView Incorporated. Let's first ask a question. Why asset creation? To make that a little bit easier to understand, let's use an example with a target product. This target product is going to be sold on an online retailer site. Now, whether this product is created in 3D by the retailer, manufacturer, supplier, or even by a 3D vendor, they have all experienced similar problems over the past number of years. Without a common set of guidelines, as these 3D models are being created, they often run into issues such as inconsistent physical scale. This usually has to do with an incorrect unit size, resulting in the product being either far too small or massively large when viewed in either augmented space or in a web-based viewer. Another common problem is inconsistent density or polygon size. Without guidelines based on the performance of the latest hardware and software, models are often far too dense for loading or providing a good consumer experience. Outside of the model itself, we also see common problems in texturing, such as inconsistent color. This often shows up as colors that are often too saturated, too dull, or just completely incorrect, which is obviously very bad if a consumer is making a purchase of the real-world product based upon the digital's representation. We also see inconsistent map or texture channels. Depending upon the viewer, the device, and the materials assigned to the 3D model itself, with a set of unknown or unexpected maps, this can lead to either an incorrect look or even worse, the product not appearing at all or looking completely broken. However, these are not the only problems that we've seen, and a small selection of some of the most common include inconsistent internal file structures, naming, and/or metadata, outdated or incorrectly topologized modeling practices such as N-GONs or T-welds, inconsistent UV scale or layouts, incorrect pivot points, non-Pbr based materials and maps, inconsistent map naming, unsupported material types, incorrect color space, unsupported or outdated texture types, and incorrect or unsupported publishing target specs such as polygon count, texture aspect ratios, texture sizes, reduced draw calls, and overall file size. So, what is the solution, you might ask? At Khronos, we took these issues and endeavored to create an initial set of asset creation guidelines. We set out to create a consistent approach where a 3D model that was typically used for a catalog or website images could have a common set of guidelines to create a consistent real-time based asset using Pbr-based materials and textures, stored in an exchange or authoring format that can then be distributed to multiple publishing targets and variants, such as mobile AR versions on iOS and Android, a VR planner version, web catalog versions, and floor planner versions. We also wanted to make sure that it was an open set of guidelines to support future publishing targets as well. Well, we're happy to announce that version 1.0 is now live. The first version of the guidelines includes summaries on file formats and asset structures, coordinate systems and scale, geometry, UV coordinates, materials, textures, lighting, and publishing targets. Please use the QR code or the direct link to download these guidelines and review them. Now, even though these guidelines are out, We're now already working on workflows and expanded guidelines with more details coming soon. I hope you've enjoyed this brief presentation, and thank you for your time.
Thank you, Nathaniel. It's great to see 3D Commerce and Jltf working so closely. Now let's change gears to virtual and augmented reality. Openxr is the Khronos standard for portable AR and VR, and it's rapidly gaining widespread industry adoption. And we have Brent, the Openxr chair, here to give us the latest update.
My name is Brent Insko, and I'm lead XR architect at Intel and the working group chair for Openxr. I'll start by discussing what Openxr is, why we needed yet another standard, and where we are today. Openxr is a royalty-free open standard that provides high-performance access to augmented reality and virtual reality platforms and devices. As a note, I'll be using the term XR throughout the talk, which include AR and VR and MR and any other similar technologies. Openxr handles communication to and from an application and an XR platform or device. An XR platform provides the application information such as the head and hand position information about the controllers and the input state such as whether a button has been pressed or released, and also display configuration and form factor information such as whether there is a single display or multiple displays. The application provides the XR platform an image or images to display, audio, and also haptic responses, such as vibrational responses in controllers. Before Openxr, an application developer would have to program each platform's proprietary API. This becomes a daunting challenge as you support more platforms, both from a development perspective, but also a validation and testing perspective. Openxr enables application developers to program to a single, common, high-performance API, which supports a number of different AR and VR platforms. Openxr contains everything an application needs to drive XR devices in a system, including device discovery, event processing, sensor tracking, and pose calculations on the input side, and frame display timing and composition, plus haptic controls on the output side. Openxr is used alongside a rendering API such as Vulkan to generate imagery. Openxr can be used with any 3D API, but a new generation API such as Vulkan is particularly well suited to create applications with high rendering performance and a low latency that are so vital for a compelling XR experience. So this is a high-level overview of a possible Openxr application, and it's just to give an example of the flow of the program and the steps involved. We don't have time to get into the details today, so I encourage you to check out our GitHub repository and member company sites for sample code to start from. This July, we gave a one-year update after the release of the 1.0 specification at SIGGRAPH last year. We have launched the Openxr adopter program and open sourced the conformance test suite on GitHub. We have a number of Openxr conformant platforms and additional developer preview implementations. And we have also released hand and eye tracking extensions for advanced user interfaces. So now I'll talk briefly about the latest developments with Openxr. In October, Unity announced upcoming Openxr support by the end of the year on partner platforms, with further support coming early next year for all conformant Openxr 1.0 runtimes. Also in October, the Blender Foundation, the organization behind Blender, the free open source 3D creation suite, has joined Khronos. This enables them to help shape the future of Openxr, Vulkan, GLTF, and many other Khronos APIs. We also have two new conformant implementations. We have the Oculus Quest 2 and the HTC Vive Cosmos. Given a current implementation status update, we currently have conformant implementations including the Microsoft HoloLens 2 and all Windows Mixed Reality headsets. For Oculus, we have the Rift S on the PC, as well as the Quest and Quest 2 all-in-one devices, and we have the HTC Vive Cosmos. For developer preview implementations, we have Valve with a preview implementation on SteamVR. We have Vario with their various headsets, and we have an open source implementation named Monado, provided by Collabora. With these initial conformant devices, we can really show off the flexibility of Openxr. We have devices that cover both AR and VR. We have devices that are tethered to a PC, as well as all-in-one devices. And we have devices that support Android as well as Windows. By the end of the year, Openxr will have wide support across game and rendering engines. Unreal Engine has supported Openxr since last year and has since released improvements around performance and mixed reality capture. Blender has supported Openxr since its 2.83 release in June, using Openxr for VR scene inspection. And as mentioned earlier, Unity support is coming very soon. It's still early days for game support for Openxr, but Microsoft has announced that Minecraft's new Render Dragon rendering engine is building its desktop VR support on Openxr. Openxr has been integrated into Chromium, the open source browser project, and with release 81, Openxr is the default backend for Webxr support. This enables Google Chrome and Microsoft Edge browsers to use any Openxr compatible device. We've also released, as I mentioned earlier, cross-vendor Openxr extensions for advanced user interfaces, including hand tracking and eye tracking. And to give a bit more detail on the Openxr hand tracking extension, it's a multi-vendor extension which enables applications to render fully articulated hands in XR experiences and to use these virtual hands to interact in XR. It includes all the major hand tracking solution providers in XR on the same standard and includes support for a wide range of hand tracking technologies, such as optical hand tracking from Ultraleap, Oculus, Magic Leap, and HoloLens, as well as controller-based hand tracking, such as the Valve Index and Oculus Touch controllers. There is also an experimental overlays extension. This extension allows overlays apps to insert their content into another application's world. This extension was added to Openxr in version 1.0.8. Developers who want to test out overlays and provide feedback regarding the extension can try it out on Collabora's Monado on Linux, or download the work-in-progress API layer from LunarG and Pluto VR on Windows. LunarG has made the API layer source available on GitHub. We've also mentioned briefly earlier the developer preview implementations, and one of which is Monado. Monado is a fully open-sourced permissive license provided by Collabora and community. It's currently passing conformance, though it's not yet a fully conformant implementation, and it supports overlays and has Android support. We also have member companies helping to advocate for Openxr. Holochip is creating a set of resources for Openxr developers, which will be accessible on their website. The resources will cover the basics of setting up an application, the Openxr development environment, including the Openxr SDK, runtime, device driver, and a sample application. It will also cover modifying the runtime functionality, such as the SLAM implementation, and creating Openxr extensions. Holochip also offers consulting services in support of Openxr. So now is the time to get involved with Openxr. Khronos has open sourced the conformance test and launched the adopters program. We have officially conformant runtimes from Microsoft, Oculus, and HTC. We have preview implementations from Valve, Vario, and Collabora. We have hand and eye tracking cross-vendor extensions for advanced user interfaces and the experimental overlays extension. And Openxr is being used by real software today. We have Unreal, Blender, Chrome, Edge, and soon Unity and Minecraft support. Thanks, and visit our website for more information.
Thanks, Brent. Next, we have Tony from HTC. HTC is one of Khronos' Asian members and, of course, one of the industry's leading VR vendors. And HTC has an exciting announcement about Openxr.
Hello, everyone. This is Tony. I'm Director of Vive R&D team and responsible for Vive SDK development and management. Today, I'm going to share our Openxr developer preview on Vive Cosmos. HTC, as one of the contributors of Openxr, we observe at least 3 major benefits for us. Firstly, join working group and participate in spec development, discussion, and maybe initiation for some specific topics and projects. During this discussion, we can also learn valuable opinions from different partners and members. Early access to draft version of this spec and relative information can help us to leverage with our internal development. Secondly, participate and vote in working group. Also, we have attended the comprehensive conformance testing and also become as adapters. Lastly, from marketing perspective, to present and demo at trade event, seminars, and webinars. For instance, like SIGGRAPH, GDC, and etc. As a supporter and member of Khronos Openxr Group, we are very happy to share HTC is announcing our Openxr runtime for the Vive Cosmos and pass conformance testing and now an official adapter on Openxr. The runtime is available online for Vive Cosmos developer preview. You can join the Vive Cosmos developer community forum for more details and learn how to download our Openxr beta for Vive Cosmos via the Vive console. We encourage the developer to support the Openxr standard with this beta runtime and also share with your feedback for us for future improvements. Thanks for your time. Bye-bye.
Thanks, Tony. It's really great to see HTC support Openxr. Up next, we have an update on WebGL, which is the Khronos standard for bringing 3D graphics to the web. And I'm very happy to introduce Ken, the WebGL chair, who's going to bring us up to speed on the very latest in 3D for the browser.
Hello, everybody, and welcome to the WebGL updates for SIGGRAPH Asia 2020. My name is Ken Russell. I'm the chair of the WebGL working group at Khronos, and we're glad that you're joining us today. We have a packed agenda for you. We'll go over some cool WebGL stuff, discuss universal availability of WebGL 2, some improvements in both the Firefox and Edge web browsers. We'll talk about higher quality universal compressed textures, higher bit depth textures, improved geometry batching, and future directions for the WebGL API. So first off, cool WebGL stuff. There are lots of great websites and products using WebGL that are released every day, and Khronos' WebGL working group tries to find and highlight these to the community. They're sent via email every couple of weeks to the WebGL dev list and also archived on this blog. Please check the slides for the links. We hope that you'll join the community and share your own creations and findings. So one significant announcement is the universal availability of WebGL 2. WebGL 2 is finally coming to all major operating systems, iOS in particular. This has been a collaboration with Apple since June 2019, and the way that it was done was by integrating the Angle project into WebKit as that rendering engine's WebGL backend. This is available for testing now as of October 2020 in Safari Technology Preview on macOS and the Safari that's in the iOS 14.2 betas. This change offers significantly improved WebGL 1 conformance. WebGL 2 is also passing greater than 98% of conformance, and of course we are aiming for 100%. You can follow progress of the project on Apple's Bugzilla issue tracker, and basically as a developer you can now rely on availability of WebGL 2 essentially everywhere. So please update your applications to WebGL 2 now. In the Firefox web browser, it's now offering improved WebGL sandboxing. The browser is strengthening its WebGL security by adding a GPU sub-process. The WebGL API calls coming from JavaScript are sent to this process for validation and execution. The JavaScript process itself no longer accesses the GPU directly. This technology is shipping today in Firefox Nightly on Windows and macOS, so please give it a try and report any issues that you see via product feedback. Microsoft's Edge browser is offering better Webxr performance with a couple of improvements. First, OVR Multiview is on by default, and this improves performance of XR content on the web in general. Microsoft is also adding support for multiple GPUs to Chromium on Windows for XR scenarios. Try out the experimental support via the enable blink features equals Webxr multi-GPU command line argument. As you may remember, Binomial LLC released Basis Universal as open source last year. This technology offers one single super compressed texture format for all GPUs. It provides the advantages of GPU compressed textures with the file size of JPEGs. Binomial is now offering a WebAssembly module that works in all browsers, and Khronos' own KTX 2.0 specification incorporates Basis Universal's technology. There is a tutorial on using Basis textures in 3.js, and now there's also a KHR texture basis extension for GLTF, meaning that it's easy to embed these super compressed textures into your 3D models and transmit them over the web. WebGL itself now supports BPTC and RGTC compressed textures, and these enable higher quality super compressed textures on the web. Customers have frequently requested higher bit depth textures as well, and these are now supported in WebGL via the XTexture Norm 16 extension. This extension is community approved and shipping in Chromium today. It provides new 16-bit signed and unsigned normalized fixed point render buffer and texture formats for better memory usage and precision. The extension is widely available on devices with hardware support, and several driver bugs have been worked around and reported to hardware vendors. The extension is available to C++ applications via Emscripten, and support for decoding images that contain 16 bits per channel is being implemented now. Recently, the WebGL working group has been focusing on improved geometry batching on feedback from customers that they wanted improved draw call performance. The WebGL multi-draw extension is now community approved and significantly reduces the CPU overhead of issuing draw calls. This extension is widely supported across devices supporting instanced draws, which nowadays is pretty much all hardware. The results from micro-benchmarks are impressive. There are 3 to 6 times improvements in the common case and reductions of CPU overhead of up to 70 times in some situations. This extension is available in Emscripten to C++ applications. Next, there are 2 extensions that finally expose base vertex and base instance functionality. These help reduce CPU overhead with static batching and provide better instancing functionality. They're available on most desktop and the latest mobile platforms with emulation of the base instance functionality when necessary. These extensions are offering good results in micro-benchmarks, and they also provide better functionality and simplify applications. You can test these 2 extensions in Chromium today with the Enable WebGL Draft Extensions command line flag. And when you do so, these extensions are also available in Emscripten to C++ apps. Now, where is WebGL going in the future? The performance and quality of all the WebGL implementations out there will continue to be the highest priority for the WebGL working group. And customers' requests for their highest priority WebGL extensions will be considered on a case-by-case basis. The future evolution of GPU-accelerated graphics and compute on the web is being developed by all browser vendors in the W3C's WebGPU community group. And we encourage you to please sign up for the community group and participate in the development, try out prototypes, and give us your feedback. Thank you. Please come to the live Q&A session, December 10th at 10 a.m. Singapore time, or December 9th at 7 p.m. Pacific time. These two are the same session. Thanks a lot.
Thank you, Ken. It's always amazing to see the significant innovation that WebGL enables. And next, we have an update on Vulkan, the new generation GPU API from Khronos, from Tom, the Vulkan Working Group Chair.
Hello, my name is Tom Olson. I work for ARM, and I'm chair of the Vulkan Working Group. I'm here to tell you about what's been happening in Vulkan over the past year. But before I do that, I want to say a word or two about what Vulkan is. Briefly, Vulkan is a modern cross-platform API for high-performance graphics and compute using GPUs. It gets its hardware model from OpenGL and OpenGL-ES, and its architecture and design philosophy from AMD's Mantle. What does that mean? Well, a traditional API like OpenGL presents you with a very high-level abstraction that does not look very much like the underlying GPU. To make that work, you have to have a large, complex software driver to do things like memory management, synchronization, error checking, high-level shading language compilation, and so on. It's convenient for the application, but there are problems. The driver uses a lot of CPU cycles. It's hard to understand and it's hard to optimize for. And because the driver doesn't know what the application is trying to do, it is often unable to make good decisions about how to do it. In Vulkan, on the other hand, you get a very thin abstraction, which looks very much like the underlying hardware. Most of the complicated functionality moves out of the driver. Shading language compilation moves offline. Error checking moves into separate optional validation layers, which you use only at development time. And memory management and synchronization move into the application. That's more work for the application, but because the application knows what it's trying to do, it can often do a better job than the driver could. And because the driver is simple, it's easy for the application programmer to predict how the driver will behave. Vulkan has been shipping since 2016. It's available now on a wide variety of desktop OSs, platforms, consoles, etc. There's a lot of great AAA content shipping on it. In mobile, Vulkan is available on essentially all high-end premium Android devices, and there's great content shipping there as well. So that's what Vulkan is. Now I'll talk about new functionalities since last year. Only the highlights. There's more than I can talk about today. So we released Vulkan 1.2 in January. As usual, we created Vulkan 1.2 by bundling together a number of extensions created earlier. And since that functionality is really more than a year old now, I won't say much about it. I do want to point out that a lot of effort went into making Vulkan 1.2 work really well with HLSL as a first-class shading language. A lot of developers told us that they prefer to write their shaders in HLSL, and we heard them and responded. You can, of course, still use GLSL as you always could. There's lots of other good technology in Vulkan 1.2, and it gives us a good foundation for the future, but I don't really have time to talk about it today. In March, we released the provisional Vulkan ray tracing extensions. Provisional means that they're not finished yet. We're still working on them, but we're exposing them to the public in order to get feedback and make them better. The core ray tracing extension allows you to build acceleration structures either on the host or on the GPU, and then cast rays into them either from a new kind of pipeline called a ray tracing pipeline, or using ray queries from the existing compute and graphics pipelines. In addition to the core ray tracing extension, we have two helpers. Pipeline libraries help you deal with the combinatorial explosion you get when you have to combine 5 different kinds of shaders to make a ray tracing pipeline. If you have to compile them all together at once, you end up with a very large number of combinations. The pipeline libraries let you compile the different stages separately and do a lightweight link at the end. There is also the deferred host operations extension that allows the driver to parallelize heavyweight host operations, such as constructing acceleration structures, by breaking them into chunks and dispatching them to a application provided thread pool. The status is we've gotten good feedback on the provisional extensions, helpful, useful. We've incorporated it, and we're working toward final specifications. We're making good progress. I cannot give you a date, but we're very satisfied with our progress. Another new piece of very interesting functionality is what we call the fragment shading rate extension. If you're a DirectX programmer, you call this variable rate shading. So when Vulkan draws a triangle, it generates a fragment for every pixel that the triangle overlaps, and generates a fragment shader invocation to compute colors for that fragment. If you're working on a 4K screen, that can be an awful lot of fragments. What fragment shading rate extension allows you to do is generate fragments on a coarser grid than the pixel grid. So for example, you can generate one fragment, which generates colors for a 2x2 quad of pixels, or even a 4x4 group of pixels from a single fragment and a single fragment invocation. This can save you a lot of GPU execution time. Of course, there's a price for it. You get less detail in the image, but often that doesn't matter. And often it's a good trade-off because you're drawing something that you know the game player isn't going to see very clearly, so it doesn't matter if you lose some detail on it. You can specify the shading rate in several ways. At the top level, you can put it into the command buffer to affect a specific draw call if you know that the whole object that you're drawing isn't going to be seen clearly. Or you can compute a shading rate in the graphics pipeline and send it down to the back end to affect a single primitive. Finally, you can split the screen into rectangular subregions and provide what's called a shading rate image or shading rate attachment, which is a low resolution image where each pixel tells you the shading rate of a corresponding region in the output render target. You can even specify all shading rates by all of these methods at once. If you do that, there are rules that specify how they're combined in response to combining rules which the application can provide. There's other new functionality. It's mostly small stuff, and I don't have a lot to say about it, don't have time to say a lot about it. I do want to point out that a lot of what we're doing is devoted to supporting better development tools. We think making Vulkan easier to program is mission critical for us, and we're doing our best to support that. I also want to say, if you find the large number of extensions that we generate confusing, we hear you, we're sorry. We are making a systematic effort to document our extensions better, specifically so that when a new extension comes out, it's clear to you why it exists. What problem is it trying to solve? Who should use it? And possibly who should not? So look for that information. It's in the overviews in the specification. It's also in the man pages, which we now provide for each extension. On the ecosystem front, the folks at LunarG have been doing lots of great things with the SDK. The most exciting of those from my point of view is synchronization validation. Synchronization, of course, is very hard to get right in Vulkan. And if you don't get it right, terrible things happen. So this gives you a validation layer which can scan your commands and detect places where maybe you are creating a race condition without realizing it. So the phase 1 version of sync validation came out in August. It detects memory hazards between commands in a single command buffer. And the LunarG team is working in future phases to extend that to a wider range of use cases. That's going to be great. There's a new Vulcan configurator to help you discover and make use of the layers that are installed on your system. There's a new trace and replay tool called GFX Reconstruct. And there's significantly better error reporting. So when you get a validation error message now, it points you straight to a specific validation statement in the specification telling you the application did something which violates this constraint, and therefore there's a hazard and we cannot predict what will happen. So that helps you find and fix your bugs more quickly. On the developer relations front, you may not have known that Vulcan has its own developer relations organization. His name is Chris. Say hi, Chris. Chris normally spends his time organizing developer outreach events, meeting with developers and talking to them. In the age of COVID, of course, that's on hold. So instead, he's been spending time curating and collecting resources that are out there and making them easier to find. Along with that, he's been working with other members of the group and with external developers to collect some of the best sample codes that are out there on the internet, bring them together in a Khronos managed repository called the Vulcan Samples Repository. This, of course, done with the cooperation and in many cases the help of the people who wrote those samples. We're very grateful for that. Finally, Chris insisted that I show you a list of some of his favorite recent blogs and videos, which you should all go out and watch. In closing, I'd like to thank the people who make this progress possible, the members of the Vulcan Working Group. Sadly, this is a rather old picture of them. We have not been able to get together face-to-face for more than a year now. I hope that soon we'll be able to meet again, just as I hope to meet all of you at SIGGRAPH Asia, at SIGGRAPH GDC, or wherever else graphics programmers gather. Thank you for your time and attention and for the work that you do. I look forward to seeing the amazing things that you are going to do with Vulkan.
Thank you, Tom. That was awesome. Before we finish, I would like to quickly introduce Khronos' newest working group that was announced at the beginning of March 2020. ANARI is defining an API for analytic rendering or scientific visualization. ANARI is at a very different level than Vulkan. It gives scientific visualization applications a portable cross-vendor API into high-level renderers, such as NVIDIA's VisRTX or Intel's Osprey. Those renderers in turn call down into low-level acceleration APIs such as Vulkan or OpenCL. Applications using ANARI will just simply describe objects in a scene and let the renderer take care of all the rendering details. Providing portable access to ray tracing renderers was a key motivation behind ANARI, but ANARI will also be able to drive any type of renderer. ANARI was initiated by Intel and NVIDIA, but is getting strong industry support from the broader visualization community. This group has really just started work, and these things typically take around 18 months or so to deliver a first specification. And so if anyone here is involved in ray tracing for scientific visualization, please consider getting involved to ensure this new API meets your needs. So that's the last of the APIs we'll be reviewing today. Hopefully this hour has given you a good insight into Khronos' latest activities. Khronos remains committed to playing a vital industry role by providing a safe space for communities to cooperate, to create open standards that benefit their own business and the wider industry. If your own company is using Khronos standards and you would like a voice and a vote in how these standardization activities evolve, or you wish to implement any Khronos standard on your silicon, Khronos warmly welcomes any company that wishes to participate. And as I mentioned right at the beginning of the session, 30% of Khronos' membership is based in Asia, and for many Asian companies, Khronos participation is an effective way to interact with international markets and partners and directly grow your business. Khronos has local representation in Asia with Dennis in Shanghai and Takashi-san in Tokyo. If you have any questions on Khronos participation, please reach out. We will be delighted to hear from you. And lastly, all of our presenters will be available at the SIGGRAPH live Q&A on December 10th, Singapore time, or December 9th, Pacific time. We hope to see you there, and we look forward to answering any questions that you may have. Thank you.